Hello everyone, welcome back. We are continuing our program with our first talk from the data science production track. Our first speaker of the day is Vladimir Ageev, who is a senior data scientist from EPAM Systems. EPAM Systems, since 1993, has leveraged its advanced software engineering heritage to become the foremost global digital transformation services provider, leading the industry in digital and physical product development and digital platform engineering services. Vladimir today will be talking about building a recommendation system for video hosting used by thousands of employees. Vladimir will describe how the project is organized, ML approach they use, and issues they are facing, what the business goal is, and etc. In addition to that, Vladimir will cover some of the other recommendation system use cases they have in their company. So please give a warm welcome to Vladimir and his talk titled On Building a Video Recommendation System and Other Use Cases.
So, hello everyone. Thank you for introduction. No pressure after this nice video from our marketing team. So my name is Vladimir, and I'm really, it's an honor for me to actually talk here live since the pandemic. Today I will talk about one of our projects on building a recommendation system. But first I would like to introduce you to the team. Oops, this clicker doesn't seem to, oh, it works. Okay. So I'm a senior data scientist at EPAM with experience in recommendation systems and NLP. But the most part of what I will be showing today and talking about today was built by Vera and Vadim. So I wanted to give them a shout out. And I will wanted to go over like different layers of recommendation system project to show that it's not only about the modeling, but about business and quality measurements and actually deploying the model. So I will go over these like 4 questions. I will start with business goal and the product itself, like what exactly we are building, what purpose of that product, what role recommendation system has in this product, and why we decided to have it there. We'll give some technical details behind the system, what kind of models we use, how we orchestrate them, and finally we'll tell you how do we measure quality of such models. So our product is an enterprise video management system for a company with thousands of employees from different countries with different skill sets of different levels. And those employees, they generate and consume very different types of content. For example, those might be recordings of important local events or important practice events like business analysts town hall. Those might be some recordings of meetups or some well-being festivals we have in the company, like this keeping your work-life balance during remote work. And finally, those might be some recordings of the technical meetups. So it's a technical content. So all this content, we wanted not just keep it in the company or make it available for search, but also somehow expose it to people so they receive interesting and relevant content in the right moment and in the right context. And why do we might need that? For example, we have a junior who just joined the company, and we would like to onboard them to all the internal systems and culture of the company. So we want to show them some introductory video or onboarding content. On the other hand, we might want to highlight some important local event. For example, we have a new office opening, or just an announcement from one of the managers. And finally, but most importantly probably, is that we want to make this content available for the employees so they can learn from it, so they can reuse those technical recordings or some project showcases, so they learn them and make their best to achieve better results on, for example, new projects. So there might be multiple ways on how to organize personalized distribution of such content. And one of them is actually building a recommendation system. So some engine that will deliver that content in right context to right people. And then I'm saying context, I mean things like this. So, for example, we have a blog post in our company blog about Serbian office, and we would like to show video recommendations connected to this article. So enrich it with the content so a person could get more details on the topic. We also have a video hosting page. This is basically an entry point to all the video content we have in the company. So a person might search for something there. And here we built a personalized blog, which shows like the content we think is most relevant for a person. For example, something similar to what we already watched, or something trending in their location, or just something most popular for their role. And another context is events page, for example. So if we have some meetup recorded or upcoming, we will show similar events or recording of similar events near that event page. So this was the business goal and how we kind of decided to do that. Now we need to start actually building our model, our engine. And usually this starts with collecting the data and selecting your target. So how do you define what is relevant content to a person? In recommendation systems, if you have any experience with that, there are usually two types of feedback, implicit and explicit. In our case, example of implicit feedback might be impressions. So if a person see a recommendation or a video, did they click on it or watched it? And their overall activity. So what they watched, then they watched it, and for how long they watched it. In our case, this is what we call view ratio. On the other hand, there is explicit content, like likes of the videos, or likes and dislikes over the suggestions themselves. So if we show them a recommendation, they might say if it's relevant or not. And finally, it might be something like addition to their watch later playlist. What I wanted to highlight here is that defining such target is not that trivial. So in our case, we decided that it should depend on the duration of the video itself and on when a person interacted with the video last time. So this is a quite complex slide probably, but the idea here is that for different lengths of videos, we decided to have different thresholds. When we say, okay, if a person watched 3 hours of a 5-hour long meeting recording, then probably they think that this is relevant for them. And on the contrary, for short videos, like 10 minutes videos, we would like them to watch more of it, like 8 minutes maybe out of 10. And for those that are relevant, we put target 1, and for those that are irrelevant, target is -1. We also weight them based on time. So the most recent views of the content are considered more relevant by the model, and on the contrary, views from like 3 months ago are not that relevant for the person. Okay, so we defined the target and collected the data. Now we can finally come up to the modeling part. In our case, we've built what is called a hybrid recommendation system or multi-stage ranking system. As it's called, it has several steps. So in the first, in the left side of the slide, we have a part that generates candidates. So given our data or on user activity, like user ID, item ID, and the target we just defined, and the video corpus. Now, in case of this project, this is a rather small corpus with about 100,000 of videos. We can do collaborative filtering over that, and here we use LightFM for that. It allows us to do matrix factorization, but with respect to ranking objective, because in recommendation system, what we want to output is a ranked list of items for a user to interact with. So once we generated candidates for each person, in our case, it's something like 300 videos per user. We need to filter them according to business rules, because we don't want to recommend content which is in a language a person doesn't know, for example. So once we did that, we can do a second stage. And in our case, we use LightGBM with lambda rank objective. So why we do need 2 stages at all? Why we can't just run LightGBM in the first place? That's because this model is more expensive in terms of compute. So you need to first filter your candidates. And LightGBM here just rearrange those lists of recommendations for those 300 recommendations we generated before, and uses various features on users, on content, things like seasonality or co-occurrence of several videos. And once it produced the recommendations, we can finally show them to user. But this is not the end of life of recommendations. And now we start collecting the user feedback. So in our case, those are impressions, which I already mentioned, like dislikes over suggestions, and viewership statistics. So all this goes into the first step and as the features into the second step. But this approach works quite well only for content which is quite popular or here for a long time, and for users who are rather active on the service. In recommendation systems, there are usually 2 problems connected with that. Cold start over users and cold start over content. And remember that we also wanted to show recommendations based on user context in those articles or events. So we need to do something about that. So as for cold start for the users, we decided to go in a quite a simple way. So we just recommend most popular videos or videos popular in their location and things around that. And as for the content cold start, we did to do the following. We decided to use a similarity-based approach, which basically tells you how similar your videos are, or your article and video are. And that allows us to cover 2 things. First, we can highlight content which doesn't have much of activity around it. For example, by showing something similar to users' attributes, or just showing something similar to what they already watched. But we also can apply it to those context-based recommendations and show those recommendations on a event page or on a blog page. So in terms of technical part, we did the following. From one side, we have a title, article, or body of a text. From the other side, we have title of a video. We also use transcriptions from audio. And now we can pass it to some neural network. In our case, this is a Distill-BERT model. Get embeddings of those models, of those objects. And now we can rank them against each other. So for video, we can get articles which are similar to that. And for articles, we can get videos which are similar to that. And compare them with similarity score, for example, cosine. So this covers most of our use cases in this project. We can show personalized content with the pipeline I showed previously. We can cover cold start of content and cold start of users. And also we can show those context-based recommendations on event page or a blog page. Now we need to run all this somehow. In our case, we have multiple pipelines for different use cases. But the overall idea is that all of them are somehow orchestrated with Airflow. So, for example, this big pipeline, it's a scheduled pipeline which runs every week, retrains weekly, and it just scheduled with Airflow. On the other hand, we have those contextual recommendations which need to be updated and generated once new content is available. So if we have a new article published, we have to generate recommendations for it as fast as we can. In our case, we use Kafka to communicate between different places in our systems. So if new article is published, we get a message in it in Kafka, and that triggers an Airflow pipeline to regenerate. So once we've built that pipeline and it in production, and during our experiments when we try to build as good model as we can, we need to measure quality of our recommendations. And here I wanted to highlight that there are not only like quality metrics of your model, but different levels of metrics. So you have to think how your model or service performs at product level. In our case, our goal was to expose the content and make sure that people are actually watching it and interacting with it. So at product level, we're measuring, for example, watch time from recommendation system, or what is the ratio of content consumed from the recommendation system out of all the content consumed. So this shows us how actually helpful our model is, how engaging are the recommendations. So the other level is model level. We use it when we experiment with models and features and so on. And also we track it online. So once our model works in production, we make sure that those metrics that we somehow measured online on our held out set are actually keeps us high in online. So in our case, those are map@k and hits@k. They just show how well we rank the items in the top of the list. So once we showed the recommendations to the user, we also want to track their interactions with it. In our case, those are CTR metrics. Those are click-through rates. So if a person seen a recommendation, did they click it? But we also track a so-called long CTR. So that means that if user seen a video, clicked it, did they watch it till the 80%, for example? And for us, we consider it's a successful recommendation. As for tools, we use Amplitude for such events tracking. we use Power BI to build dashboards, and this plot is actually built in Metabase, and you can see that our model score is constantly growing. Okay, so in a summary, when you're building such a project, you might consider the following things. So first, you have to think about your business goal. So you're not just building a model in a vacuum. You need to think how what purpose of that model, what value it brings. You need to define a target, and if in, for example, image classification, it might be something simple. In recommendation system or in things that are about interaction of a user with some items, that might be a bit more difficult. So then you can start building your models, and what we learned is that you not always need those complex models because they might cover like 80% of your user base, but you always have those edge cases which have to be covered with more lightweight models or approaches. And also we learned that those context-based recommendation could be easily done today with those pre-trained models. Once you have your approach established, you might want to orchestrate it in production. So this should be chosen based on your amount of data, on the schedule you have. So do you want to retrain the model or not? Do you have a batch processing, or you want to produce recommendations online and inference online? And finally, you have to measure your quality not just offline during your experiments, but also when you put your model in production to track data drift, or just to make sure that your assumptions during your experiments were valid. So this is it for this content recommendation system, and I just wanted to highlight that there are other projects in our company. I asked my colleagues to maybe highlight or recommend some of them, and here I chosen two. One is for a telecom company. They built a recommender in a mobile application. And another one, which I find interesting, is that they built a recommender system for a health and beauty retailer group, which has stores in different countries and millions of customers. And what's interesting here is that they built ranker of consumers. So they had to select consumers to do promotion for. And on the other hand, they created a recommendation system for the products themselves. So on the other hand, they have top consumers. On the other hand, they have products to try to sell them. Those are more like large-scale projects in terms of data. You can see buzzwords like Apache Spark or Apache Ignite here. And also what I found interesting, that they used Horowat for distributed training of deep learning models. That's basically it from my side. Thank you. Feel free to reach out to me, or if you found those projects interesting, feel free to check out our careers page if you're interested in. Thank you.
Thank you very much, Vladimir, for that wonderful talk. I would like to hand this certificate of appreciation for joining us at the conference and for giving us a talk. Are there any questions for Vladimir and from anyone? No? Then thank you very much. You can catch him in the hallway if you think of something.
Thank you. Have a nice week and this open day. Thank you.
Thank you very much.